Module 3, recursive algorithms. So I feel most of you have the experience using recursive functions. So this module, so we try to study this important and powerful algorithms. So we will go with a lot of depth. We need to understand, from many different angles. Part A, introduction to recursive algorithms. 8.1, first view of recursive algorithms. First, let's look at the recursive thinking. So we need to understand this recursive thinking. Here, I noticed the response time is quite slow. When I change to a new slide, it takes several seconds. All right, the question. Now a little better. Why recursive thinking is important in problem solving? Okay, we know the current high-level programming languages all support recursion. We know some very old programming languages did not support recursion. But the modern programming languages all support recursion. So here we also need to understand how to implement recursion inside computer memory. You need to understand that background a little bit. So it will be useful when you design algorithms using recursions. So you need to know its drawbacks and advantages, disadvantages. All right. So first, we're used to straightforward thinking, non-recursive, right? So, because the recursion, you need to try to get experience, get used to it, how to think recursively. Okay, so you need a training, you need a practice to get used to the recursive thinking. Because if you do not have enough training, so sometimes you cannot handle the complexity of the recursion. So but it's not hard. After some examples, some practice, so you can get there. Some problems can be solved both ways, non-recursive way and a recursive way. Most of the time, you have situations like this. Sometimes people like to solve without using recursions, but sometimes people like to solve using recursions. Okay, each one has its advantages and disadvantages. Here, I like to talk about a little bit, the main advantages and the disadvantages. The reason so many programmers, they like to use the recursion because of the power of the recursion. It's very powerful. That's the biggest reason or biggest advantage of recursive algorithms. That's the power of this type of algorithms. Very powerful. What do you mean powerful, right? Here, what do you mean powerful? Here, let me just give you the straightforward understanding, the power. What's the power? Why we say it's powerful? You can use relatively simple implementation to solve some very difficult problems. That's the meaning of the power. We know usually when you need to solve some very difficult problems, you need to write A lot of code, very complicated code to do it. Your implementation usually very complicated. But with recursion, you can make your implementation much easier. So that's the whole thing, whole property. So that's what we mean, the power of recursion. Yeah, so we like it. So we like its power. Okay, yeah. All right, so some relatively hard problems can only, but parenthesis only. Yeah, parenthesis only because there is some argument about this only thing. Yeah, can be solved by recursion. Because based on our textbook, it does not have this parenthesis. Sorry, it does not have this whole thing only. Sorry, yep. So based on our textbook, so all the, yeah, let me, I will, based on the author of our textbook, all computing problems, if you can solve recursively, then you can find a non-recursive implementation. So that's based on the textbook. But in the real world, for most of us, sometimes we couldn't find a non-recursive one. So later today, I will show you one example. So if you need to solve non-recursively, extremely hard. So that's why I put a parenthesis, around that only. Yeah. Because different people, they have different views. Yeah. Okay, yeah, but it's not important. That's just different views. Okay. All right. Now we do comparison. Non-recursive, we call the iterative way. Yeah. So you need to solve in an iterative way. So for loops, while loops, you need to use loops, but no recursion. You avoid recursion. Yeah, so that's one way. Another is recursive way. Yeah. Yeah. Because a function can call itself, so that you can avoid some relatively complicated loops. Yeah. Yeah. All right. But an advantage for non-recursively, the advantage, less resource. When you use the non-recursive implementation, usually your computer memory uses less resource than the recursive version. Okay, yeah. So that's a big advantage. Then the disadvantage for iterative implementation, usually very complicated. Yeah. So the cost, the negative side, you need to write much more code, and the logic is more complicated. Actually, not just code, the logic is much more complicated. Okay, yeah. So that's the disadvantage part. Then it's the opposite for the recursive side. You use more resource. That's the disadvantage. That's the negative side. Yeah. Nothing is free. Yeah. You enjoy the power of recursion, but the expense, the cost, you need to pay some cost, the memory resource cost. You consume, in the recursion, you consume more memory resource than the non-recursive one. So that's the disadvantage. Yeah. Advantage, easier implementation, and you can handle some complex algorithms in a relatively easy way. Okay, yeah. So here, let me explain why less resource, more resource. Yeah, so this, I need to go to the computer main memory to describe the main idea to implement recursion. How to implement recursion? high-level programming language support recursion, because right now our computer hardware, software, so advanced, so powerful. So there is nothing to worry about when we apply recursion. We have plenty of memory resource. In the old time, your memory not that big. So if you still support recursion, then you can run out of memory quickly, right? So that may not be good. You run out of memory quickly, resource quickly. Yeah. Here, let me explain why it uses more memory resource. In main memory, how to implement recursion. Recursion, yeah. Here, the main behavior of a recursion, when you call a recursive function, the function cannot return the value to you immediately. The function needs to put it to a hold. The current function needs to calculate a previous value first. After you get a previous value, then you can use it to calculate the current value. Okay, so the function needs to put the result of the current value on a hold a little bit, then go back to the previous value to do calculation. But the previous value is still not available, and put it on hold, go to another previous value, and so on. Yeah. So inside the main memory, you need a special data structure to handle. On hold, what do you mean on hold, right? In data structure, in main memory. Yeah. There is a nice data structure, simple. You can do this. The data structure is the stack data structure. Simple, stack, yeah. Okay, in CS3250, you learn this data structure, stack data structure, okay? First in, last out, right? The stack data structure has the property, first in, Fi, last out. The first item you push in, the last one comes out. Yeah. The first one, yeah, let's say first item, second item, third item, okay, yeah, yeah. The last one on top, okay, top of the stack, all right, yeah. Oh, the last in, first out. The last item you push into the stack, the first out, okay? So that's the main property of a stack, all right? Now, we use stack to implement recursion, okay? We use stack to implement recursion, all right? So let me write the recursion implementation. Okay, yeah. Recursion, yeah. Suppose we want to evaluate a function f of m recursively. Okay, yeah. So this is a recursive function. So recursively, okay. So we want to, our goal, we want to find the value of f for the variable parameter value m, and f of m, okay? Yeah, so we call this function f of m, but this function cannot return f of n immediately, yeah, because it relies on some previous results. So this f of n is not available immediately. So what to do is push f of n into the stack. On hold, yeah. We need to do calculation of f of n minus 1, some previous parameter value first, okay? F of n minus 1, let's try to see if we have that previous value, okay? So we need to get the value of f of n minus 1, but it's still not available, then we push it into stack, f of n minus 1, okay? Another one into stack, right? Yeah. And it relies on f of n minus 2 and so on. So you keep pushing into stack. If unknown, not available, you keep pushing into the stack, okay? Yeah, until you reach at some point on top, it is available, f of 1, suppose. When you reach the top, f of 1 is available. Now it's available, okay? You can use it, calculate f of 2, available, f of 3, and so on until you reach the bottom calculation. You'll find the final value of f of n. Then you return it to the user. But you need to go through all those things, okay? That's the internal implementation of the stack. Now you can understand why it consumes much more memory, because the stack could be very deep. The stack must be inside the main memory, okay? The main memory, you know, there is a limit of the main memory, right? Memory resource limit, several gigabytes. Yeah. My laptop only 4 gigabytes. Okay, your Mac probably larger. Okay, yeah, 8 gigabytes or 16 gigabytes. Here I talk about main memory. Okay, not hard drive, main memory. Okay, all right, several gigabytes. Yeah. Then, when the stack is very deep, you can imagine a lot of resource is used. Yeah. If the memory resource is consumed too much, it could impact your performance, response time. It could impact, okay? Yeah, it could slow down your algorithm if too much memory resource consumed in your algorithm. So that's the biggest drawback of recursive algorithms. That's the pay. You have to pay this much cost to get its power. So, all right, yeah. So here, you know, give you the advantage and disadvantage. Yeah. But we still want to keep it. We still, because it's so powerful. We like its power. So we are willing to spend this much memory resource to solve a large class of computing problems. Yeah. All right. So that's the